All right, go ahead and put today's date at the top. Solve systems with 3 variables. Now the idea, whether you're using substitution or elimination, is that you need to take what we've done on our quiz on Friday. We needed to take equations that had 2 variables and somehow make it where there was only 1 variable. Whether we use substitution and we replaced and rearranged and plugged something in so that we only had x's, or whether we eliminated y so that we only had x's. The idea was to get it where we only had 1 variable, right? You with me? That's still our goal, is to take these equations and get it to where we only have 1 variable. But it's more of a process. There's more that we have to do to ease ourselves into that. So write example 1 with me. The first 3 variable system we're going to have, first equation, 2x plus 4y minus 5z. If you are not one who typically crosses your z's, do that for me right now, because it is a shame to do a half a page of work and then mess up because we thought a z was a 2. All right? So do that with me. Just be super neat. Equals 18. Our second equation is negative 3x plus 5y plus 2z is equal to negative 27. And our third equation, negative 5x plus 3y minus z is equal to negative 17. Now, this is an example of one that is going to take you the most work. A lot of times you're going to have a system of 3 variables where one of the equations may only have x and y in it. Or you could even have an equation that only says something like negative z equals negative 17. When that happens, that's going to be easier than this for this specific scenario. This is more like the hardest case. This is the most steps that you would be involved in. You with me? All right, so we need a plan. We need a plan for how to figure out what these variables are when there's so many and nothing is isolated. Now, you know you're confident on solving a 2-variable, 2-equation system, aren't you? You feel like if we could get this to where we only had 2 variables to deal with and 2 equations to deal with, then we would be fine. We could deal with that, right? So our strategy here, when I have 3 systems with 3 equations with 3 variables, is to choose 1 variable to eliminate in order to create a 2-variable equation. Instead of trying to get down to a 1-variable equation to start with, let's just see if we can eliminate one and get down to a 2-variable equation. You know what I'm saying? All right, so let's look at the x's. Those x's are not really there's not really a whole lot they have in common, is there? I'd have to change, if I did these 2 x's or these 2 x's or these, I'd have to change both of them. I'd have to multiply both of them. What about the y's? Again, not a terrible lot in common, right? But look at the z's. Now, there's not a right or wrong here. You can eliminate any variable you wanted to, but I want to draw your eyes to why z would be a good one to eliminate here. If I wanted to take these bottom 2 equations right here and eliminate z, what would I have to do?
Times it by 2.
Multiply the bottom one by 2, right? You with me? What if I wanted to take the top one and the bottom one and eliminate z? What would I have to do? Multiply the bottom one by negative 5 to change this to a positive 5z. You see what I'm saying? So z looks like a good option to get rid of. My plan, if I could get rid of z and have just an xy equation and another xy equation, then I can solve that, right? You understand the plan there? All right, so let's take, I'm going to try to use a little bit of color coding here to help this make sense to you. Let's take equation number 1, equation number 2 and equation number 3, and let's try to eliminate z. That's going to be my first plan. Eliminate z. All right, so my top equation, my middle equation right here, that one can just stay itself, And what did you say we were going to multiply this bottom equation by to eliminate z? If we're just using the second and the third equation, we'll multiply it times 2. So yeah, I'm going to put the second equation, I'm going to multiply it times 2, giving me, careful here, negative 10x plus, come on guys, 6y, good, minus 2z, very good, equals negative, careful, negative 34. Details are going to be huge here. Be super careful. All right? And that second equation can stay just like it is, and we will eliminate z. Everybody agree? So just write that second equation again, negative 3x plus 5y plus 2z equals negative 27. Draw a line under that. Combine those two equations to eliminate z. Go. You do it. All right? We good? You have negative 13x plus 11y equals negative 61? All right. So what that is a two-variable equation. Draw a little star by that. That's excellent. That's a two-variable equation. You can make yourself a little key up there. There's my first two-variable equation. Just making myself a little note here of what I've done. Now, I need another two-variable equation to come from here so that I can use my old standard substitution or elimination here. So I need to take, I've done the bottom two equations. I've done equation number 2 and number 3. Now I need to pick a different combo. I could do 1 with 3. I could do 1 with 2, right? I just have already done 2 and 3, so I've knocked that out. Which would be a better option? Would we rather take 1 and 3 or 1 and 2? 1 and 3? Everybody agree with that? Okay, so I'm going to take I need another color. Pink. That's red. Whatever. All right, I'm going to take equation number 1 and equation number 3. And what did you say, Jason, again? I was going to need to multiply in order to eliminate z, because I need to eliminate the same variable again. You with me? So that I'll be left with an x and y. So you said times negative 5. All right, so I've done that one. Now I'm going to take this equation and I'm going to multiply this equation times negative 5. I'm going to do it way over here to the side. I'm going to kind of draw myself a little line right here, and I'm going to do it over here. Multiplying this equation times negative 5. You with me on what we're doing? All right, so let's multiply it. We get 25x minus 15y plus 5z equals, 17 times 5. 85? Positive 85. Now, take the first equation. Do I need to change anything on the first equation? No, but let's bring it over here, and I think I'm going to write it right above it. I'm going to take that top equation, and I'm going to write it right there as 2x plus 4y minus 5z equals 18. Take a moment and think about what we've done there, and if you have a question, ask me now. If you want to ask, why did you do that, or where did you get this number, or anything like that, ask me now. If you're pretty sure you're not understanding why I've done what I've done so far, ask me now. Let me reiterate. But I don't want to keep preaching at you if you're with me. Are you with me? Are you with me? Okay. All right, combine those. Go. I've now created a blue two-variable x and y equation and a red two-variable x and y equation. What is the benefit of that? What does that do for me now that I have a blue two-variable x and y and a red two-variable x and y? Come on. What can I do with that now? Take those two and do what with them? Do you have no idea, or you're just not talking? We can use elimination. We can stack them up, take them and stack them together, and use some elimination. All right, so there's my first equation. Let me take that second equation, put it right under it, 27x minus 11y. Now that worked out really nicely that my y's are ready to eliminate right now, aren't they? Do you think that will always be the case? Could you solve it if the 11s had not been matching and ready to eliminate? Yeah, you just have to multiply something. But in this case, we don't even have to multiply. We take our first two variable, our second two variable, our y's eliminate, and we're left with 14x equals 42. Is that what you got? So x equals what does x equal? X equals 3. We know the first part of our solution. All right, if I'm going to write my solution over here, my solution is going to have three parts. It's going to have the x, the y, and the z. I know one of them. How do I go about finding the other two? Now that I was able to get it all eliminated down and figure out what x is, how do I go from there? Where do I go? Have any thoughts? You plug in. The question is, where do we plug in? If I plug x in right here, is that going to allow me to figure out what y and z are? What about here? What about here? Okay, what about here or here? If I plug x into one of those two variables, then I can figure out what y is. You with me? All right, so go plug it in. Choose which one you're going to do. I guess I'll plug it into this first one. Take that first one and plug in. I'm writing little notes here. You probably want to write these too so you'll remember what you did there. I'm going to plug in x equals 3 to negative 13 times 3 plus 11y equals negative 61. Go ahead and solve that. What is y? Negative 2. And now that we know what x and y are, what can we do with that? Plug it into any of these three variables to figure out what z is. Up to you which one. I think I'll plug it into this top one up here. So we're going to plug in one more time. Plugging in x and y. 2 times x plus 4 times y minus 5z equals 18. And z equals? How can you know that you've gotten all of these right? How can you go back and know for sure? Yeah, you can plug it in. Maybe not to that first one since that's the one we used to figure out z. Maybe plug it into one of these and see if that works. Let's see, 3 times that is negative 9. Minus 10 would be negative 19. Minus 8 would be negative 27. You can plug those in and make sure that your answer is right. What do you think about that? Too much? It's a lot, isn't it? A lot of opportunity to make a mistake, a lot of places where you have to be super careful. Yes, Jason? it's possible. Well, no, wait. By adding all three together? Yes, but then you're left with one single two-variable equation. What is that going to do for you? You with me? That's why we take two at a time and then a different two to create two-variable equations that are true. Max?
So whenever we got negative 13x plus 11y equals negative 61.
Yes.
Like our first star. So, well, mainly my question is, once you multiply, or once you cancel that z, how do you find out to multiply by negative 5?
Okay, so when I first looked at my three variables to decide that z was the one, I was looking for not just something that I could eliminate easily once, but that I could eliminate easily twice. Like on this one. I mean, I could multiply the top equation times 3 and this one times 2 to eliminate x, right? But I have to multiply both equations. Then when I go to do a different 2, I'd have to multiply this one by 5 and this one by 2. So that one to me seemed like it was going to take more work than the others. Whereas when I looked at z, I was like, okay, this is such an easy equation to eliminate because I can just multiply just this one and eliminate using that. And then I could multiply just this one by another one to eliminate using that. So you understood how I chose to do the 2 first. So once I had used these 2, I had to pick a different 2. I could have done these 2, but I would have needed to multiply the bottom by 5 and the top by 2 and change both of them into bigger numbers.
So you just have to eliminate the z twice?
I eliminated z with one combination and then with another combination. That's exactly right.
Okay.
And I have to choose carefully what variable would be easiest. All right. Pick a partner and slide your desk over next to somebody if you want to. If you just want to work by yourself, that's fine. But I'm about to assign you one, and having a partner beside you kind of talking through it with you seems to be helpful. Pull up beside them real quick. You have 10 seconds. Go. 10, 9, 8, 7. Slide over next to somebody. 6, 5, 4. If Taylor wants to come sit by you, or that'd be fine. You can come over here. 3, 2. Look at there. Everybody has a partner. That's awesome. Here we go. Next problem. Four x minus 3y plus 6z equals 18. Next equation, negative x plus 5y plus 4z equals 48. Third equation, 6x minus 2y plus 5z equals 0. Okay, step number 1, you and your partner discuss which variable would probably be the best one for eliminating twice. You need to do it twice. Y'all discuss it, and then I'll concur or disagree with you. If you pick one, be prepared for me to say why. Why would you pick that one? Okay, A team over here, Alice and Abby. Which one did you pick? The second one, the why. Defend that for me. Why would you pick why? You said the second one. You meant why or you meant what? So you want to get rid of X. X is the one you think to eliminate. Why? Okay, we can change that one twice. We can put that one with this and just multiply it times 4. We can put that one with this and just multiply it times 6. I agree. That's what I would do. That was like a good one. Okay, so we've agreed we're going to eliminate x. We agree? All right, pick 2 equations and eliminate x. Create yourself a new equation.
It's okay to talk the whole time as you're working with your partner. Okay, I got my first two variable equation. All right, I've got my second two variable equation. I'm going to check and see if your two variable equations look like my two variable equations. Before you go any further, you want to kind of double check. Yes, Jason's group looks good. Lane, how's your group look? Did y'all get a 17y equation? No? No? Did you get a 28y equation? Did you choose to eliminate x also? The bottom, okay, what do you mean the bottom one? You have to have two. So which two? The middle and the bottom? When you multiplied it by 6? You didn't eliminate x? Okay, so you eliminated x on these bottom two equations?
I eliminated them with the first and second one, and I did the second and third one.
Okay, so let's say the second and third one. Did you multiply it times the second equation times 6?
I didn't multiply.
Well, how did you eliminate x?
I multiplied, but then I didn't use I didn't carry the multiplication to the 5 and the 4 and the 48.
Oh, okay, fix that. Okay, everybody on track? Laurel Jesse group, you okay? Ace, you good? Parker Max, you good? Okay. Now I've got to eliminate. This is terrible. Now I've got to eliminate y or z using these two equations. These numbers are about to get pretty big, aren't they? Which one do you want to eliminate? A y or z? Okay, I'm going to say y too. I'm going to eliminate y. All right? So to eliminate y, I'm going to have to, what number will 17 and 28 go into? 17 and 28. Anybody? What number will 17 and 28 both go into? Nobody's coming up with anything. At the very least, what's 17 times 28? 476. That's the lowest number they'll go into. I know that because 17 doesn't have any factors other than 17 in itself. So it won't share any factors with 28. So yes, it's just going to have to be 17 times 28 is 476. So how do I change this top equation into a 476y? Multiply it by 28. That's right. Okay, so now I'm going to take this one. In fact, I'm going to rewrite it just to keep it nice and simple. I'm going to write my 17y plus 22z, because I feel like I'm about to lose somebody if I don't, equals 210, and 28y plus 29z equals 288. Now I'm going to have to multiply that top one by 28 and the bottom one by what? Negative 17. Yeah, aren't you glad you have a calculator? Get that calculator going and let's write those two equations. We're trying to eliminate y. So 476y plus okay, I'll solve. So 5,880. Some big numbers, right? I know. I'm hiding what I'm doing so that you'll work independently and just use me to check. $4,896. That's what I got. All right. Now I can eliminate y. Who thinks these answers are going to be big, huge numbers? They're not going to be big, huge numbers. Did you get 123z? Yes? Still on track? Equals what? 984. Equals 984. And then z equals big, huge, old 8. All of that to get to z equals 8. You there? Laurel, Jesse, did y'all get there? Okay, now what? Now what? We know z, that's awesome. Don't know x, don't know y. How are we going to find them? Plug it in. That's going to be the answer. Where am I going to plug it in, though? Because, oh my word, I can plug it in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different places. Where would you recommend plugging it in? There's really two good answers. Yes, either the blue one with only 2 variables or the pink one with only 2 variables. Why not one of these 476s? There's still 2 variables, and they're just bigger, nastier numbers. They're bigger versions of the 17 and the 28, aren't they? So pick 17 or 28 and plug it in. I think I'll go with the 17. Plug it into the blue one. Equals 210. What is y? 2. We went to 5,880 to get back to 2. All right, how about x? How are you going to find out what x is? Any of these first 3, that's exactly right. Plug in to one of first 3. I'm going to go with the first one.
Okay.
It's looking like it's going to be a negative number, isn't it? So x is?
-6.
-6. There. You can stay where you are for right now. All right, now what I wanted to find here real quickly was an example of one that is going to solve out a little bit differently. One that's going to look a little bit simpler. And I see one. I see one. So take that worksheet and set it aside for just a second. I see an example. Yes?
I didn't get one. It's too bad. Oh, my bad.
Okay, I see an example here of one that's going to solve out a little bit differently, and I want to throw a different one at you so you'll realize how some of them are easier. This is the most complicated version. All right, so writing with me for our example 3 here, let's try first equation, x plus 2y equals 12. Second equation, 3y minus 4z equals 25. 3y minus 4z equals 25. Third equation, x plus 6y plus z equals 20. X plus 6y plus z equals 20. Take a moment, and you're going to need to analyze that for a second. Look at what you're looking at here. Analyze that and tell me about these problems. What do you see? Huh?
The first two are missing a variable.
Okay, the first two are both two variable, aren't they? What's missing in the first one? Z is missing. What's missing in the second one?
X.
Can you take those two variable equations and put them together and use elimination? No, it's not the same two variables, is it? You with me? You're not going to be able to combine x's and combine z's and eliminate y's because then you'd still have x's and z's. That wouldn't take you anywhere, would it? But they are both two variable equations, which could be helpful for something if I could do what? Like I have one equation that the first equation has an x and a y. The z is gone, right? So if I could somehow eliminate z and create another two variable equation, or use some substitution there to create a two variable equation, that would work. So think about it. What kind of ideas do you have? How can we tackle this? On which equation? Okay, if I isolated x on the first equation, what could I do with that? I could plug it into the third to the bottom, but then I would still have y's and z's on the bottom, although it would be a two variable equation. Yes, that's true. That could work. That's a strategy. What else? In all honesty, I'm looking at this and thinking about it too. Like, what's the most efficient way to solve this?
If you did what you said and you took your second equation and then tried to get z by itself, you could plug in for x on the last equation and also z, and that way you're only left with 65.
Okay, so isolate the x on the bottom equation.
Isolate x on the top equation.
That's what I was thinking. Isolate x on the top equation.
Isolate z on the second equation. That way you can plug in for x and c on the last equation. That way you're only left with y's.
Okay. Now, you said isolate z on the last equation. You didn't say on the second one, did you? What's going to happen if you isolate z on the second equation? You're going to have some terrible fractions to deal with, aren't you? Okay, so let's start by isolating x on the top equation. Good plan. X is negative 2y plus 12. Now the question is, where do we want to plug that in? If we plug it in on the last one, we would have nothing but y's and z's, and then we could use elimination between the second and the third because we'd have all y's and z's. Okay, that's a pretty good plan. So let's take that right there. Let's take this one in pink, and let's substitute it in down here for this one. All right? That'll give us a 2-variable equation there. So that's going to look like what? Negative 2y plus 12 plus 6y plus z equals 20. Note, this right here is the replacement for x, right? All right, so simplify that. What are we going to do with that 12? Move it to the other side and make it 4y plus z equals 8. All right, so now we have a 2-variable equation. We call that my pink 2-variable equation. You with me? What am I going to do with that now? Now I've got another 2-variable equation right there that I can stack those up and eliminate again. So I've got my pink one here. I've got my blue one here. Can you solve from there without me? Figure it out from there without me? I like these numbers a lot better than that last one. Y equals. Did you all choose to eliminate z? Y equals what? 3. Choose where you want to plug that in. Into one of these 2-variable equations, either the blue one or the pink one. And we got our z, didn't we? Okay, find your x. Okay. I tell you what, I gave you that worksheet a little bit prematurely. I'm not assigning those to you tonight. Okay? Today was our work through this day. Tomorrow we start tackling it on our own. So will you put that in your notebook and not lose it tonight? Yes.
So once you get 3, -4, I can plug it in the way. x plus 2y equals 20.
Yeah, you can plug it into that one to figure out what x is. Mm-hmm.